statue of a raccoon.
Oh, an astronaut riding a horse.
Welcome to the Hackaday Podcast. I'm Elliot Williams, Editor-in-Chief of Hackaday.
And I'm Managing Editor Tom Nardi.
This is episode 174, Breaking into the Nest, the cheapest 3D printer, a spy in your HDMI, and AI all over the place. What have we got in the news this week? Not much. My life, I've been away on vacation. I came back. My now 11-year-old laptop is finally starting to show its age.
Oh.
So I ponied up and got a new computer, which is awesome because new computers are awesome. But it's horrible because it means I have to completely install a new operating system on it and start from scratch again. And I'm one of those people who hyper personalizes everything in my system, and every time I set up a new system, I vow that I will take really good notes about how I did it and what I did. Once I think I even started up a Git repository with all my config files in it with the hope that I would continue doing that. And, after a while you just stop or you forget something. And I'm back to square zero again. It feels horrible.
See, so my thing is, if I forgot it, it must not have been that important. Those are the rules I use. When I go to set up a new machine, if I forgot it and I didn't bring it forward, then I must not have been using it very much. That's...
For sure.
Whatever's at the forefront of my mind makes it from one machine to the next. I do keep the old hard drives around forever. Storage is so cheap. I buy another drive, label the old one, put it on the rack, and then if I ever go, if I ever what was that thing I was in the middle of, I can go back.
Yeah, my laptop's still running, so I could just copy whatever config files off of that if I need to and stuff like that. So I guess I can keep on going that way if I need to.
Oh yeah, you gotta make that a digital time capsule. Just wrap it up, very carefully, put the date on it, and if I ever have to go back, what was I working on in 2022?
Yeah, no, what you discover is that you have all sorts of muscle memory built up around the way you do things. And when the system changes out from underneath you, it's it didn't work right, help. But the nice thing is that it's also kind of an opportunity to clean house, right? And so I like your approach, just see what you miss and start installing it as soon as you miss it.
But you're right, though. I have, occasionally typed out an alias that was 2 machines ago.
Doesn't exist anymore.
It comes back and it's what are you talking about? Oh, right, that's not a real thing. That was something I made up, years and years ago for some particular purpose that I can no longer remember.
Although if you look through particularly my alias file, you'll find aliases there that are 2 defunct online internet radio stations that don't even exist anymore, because I used to listen to this 15 years ago and I still have an alias for that. I don't know. That's, sometimes you do just have to clean house, and maybe this is a good excuse to do it. We'll see. I'm half tempted to try a different window manager. I use one called DWM, and I haven't changed it in probably as long as I've had this computer, probably also 10 years, because it is rock freaking solid. It is a super minimalist window manager. All it does is put windows where they're supposed to be, and if you happen to open up 2 of them, it tiles them nicely, lets you bring them to foreground and background, lets organize things in workspaces. Actually, it does a lot of crud for a program that's 500 lines of C long. But I also think this might be a chance to experiment with something new. What's the state of the art? What's the new coolness? Maybe I should just
some Wayland or something.
Splash out and do something new. Yeah.
Yeah, you'll be back.
I'm scared of Wayland.
You'll be back. You'll try the new stuff. I'm nah, not yet.
I don't know. I work on this machine. I need it to work. It's important that it can do everything it needs to do.
Yeah, that's why you have to have the play machine and then the one you actually work on every day. It is unwise for those to be one and the same.
And your travel laptop. They're all the same machine for me. Yeah. I have them all in the same machine, and I guess that makes me unwise.
Wah, wah.
Gotten away with it so far. All right, let's start up the hacks. This week, I'd like to start up with Robin Keary's piece, Working with BGA's Design and Layout. Now, normally we save our original content pieces for the end, But we also like to have kind of, I don't know what, opinion pieces that we can just riff on for a while at the end of the show. And this one is like really meaty. This is how you should design for BGAs if you're making your own circuit board that needs them. Not a lot of opinion I have on this, but boy, is it loaded with awesome tips and tricks. You need to go check it out, especially because now that there's this part shortage, I guess also just due to general technological progress, it's hard to get a lot of the coolest chips out there in pinned layouts anymore. They're all ball grid arrays. And so you are eventually going to have to deal with ball grid arrays in your PCBs. So maybe it's time to start off with something easy, experiment, get your feet wet, and that's what this article is about.
I was surprised to see this outside of its normal can't miss section in our little rundown agenda, but I'm glad you picked it because it is phenomenal. It felt like it was speaking to me personally because it kind of starts off with saying like, oh, you must assume BGA is too hard. You'll never do that on your own project. And I was kind of looking over my shoulder like, is he in the room with me? Is Robin is Robin looking at what I'm working on? And I think a lot of people feel that way, right? If you're doing PCBs, you've probably at this point moved on to SMD stuff, but the ball grid array seems like some weird nebulous further accomplishment that, is not for mere mortals, but it is serious. I mean, when I went to edit this one, I was like, oh my, it really clocks in there, but there's not a wasted word in it. I mean, it really does
for sure
go through an incredible amount of detail, and the pictures, it shows you really how everything goes together. It's awesome work.
I've played around with soldering BGAs, and this is something that, all of you out there are going to have to do someday. And my recommendation is don't be afraid. It really, as long as you get the balls over the pads, when you reflow it, surface tension just takes care of you. And, everything just works. I did this with a super low tech heat plate. I guess they must have been fairly large pitch balls, but I did 5 boards. 5 boards worked on my first try. So, you can't beat that. The trick to making the boards so that works out for you is where the interesting part, for me anyway, in this piece was, because that's all stuff that I don't know. And some of the tricks that I thought were really neat are things like the manufacturers specify they need to have no solder mask around the pad where the balls connect. And the reason for that is actually so that the balls can kind of grip on to the square edges of that little copper land where it glues to. And that's really, really cool. It's called, No solder mask D. What does the D stand for? Damn it. No solder mask defined, which means that you just leave a little extra space around the copper pad and don't butt the solder mask right up to it. Other things you're going to have to consider are, of course, how you get the lines out from under all of those tiny little balls that are all on the surface. And that's where it gets really tricky, and that's where some kind of experience is probably good for you. With the bigger ball pitches, so kind of 1 millimeter and up, you could probably basically get away with anything. But then when the ball pitch gets tighter and tighter, there's just no room to run vias out along the top side, so you have to drop them down and out. The bigger and bigger the ball grid is, so like 5x5 is probably all right, but when you get up to 7x7, 9x9, or even more balls, just the physical space in between them all gets so small that your only hope is to drill down with a via. And because the space is so tight, of course, these are micro vias. An interesting thing that Robin brings up here is that kind of below 0.65 millimeters, you're going to absolutely need an expensive/advanced board house to even just be able to drill the vias so that you can get your lines out. So this is something to watch out for if you end up having to design for BGAs. Maybe about 0.5 millimeter and below, you really need to start thinking about it, because there you absolutely have to drill the vias in each ball and send them straight down. And if you have to fan too many of those out, you're looking at a multi-layer board with ultra-high tolerance specs, and you're looking at a lot of money. because, as Robin says at the very end, there's little point in replacing an unobtainium chip with an unmanufacturable PCB. A bunch of our audience really keyed into this article, which I thought was really neat. Rick C. told a story of what would be kind of a $5 board, but because he needed to get it to fit this BGA part with such, high precision requirements, it would have cost him $300. So he just didn't get it made. Jeremy used to do this in industry and routed a 1500 pin FPGA. And he says the only way to get those things broken out was to do a 12-layer board with all with vias and pads. And he says at this point, there's just no way you're going to route 1500 lines. So you use the auto router to kind of break them out around the BGA part itself, and then you can route them from there on out. And I thought that was neat because I know Chris Gamble's shtick about don't trust the auto router, and he's right, of course. You really have to watch out for the things. They will do stupid things for you. But on the other hand, when you get to a certain level of complexity, you just don't have any hope to do it otherwise.
Yeah, really.
And finally, a couple people, Ward and JPA, came in with a great idea. In order to place the balls on their pads, you can't see under there, right? So usually you put a silk screen around that shows you where the part has to go, and you kind of hope that that aligns it. But a lot of board factories don't pay the same attention to their silk screen's precision that they do to the copper traces. And so Ward and JPA both suggested you could send out traces out at 45 degrees from all four of the corners. And they kind of make like a crosshair that shows you where you need to put the part. And because the board shops will pay a lot of attention to the precision of the routing of the traces, you can use that to get the BGA spot on in the middle. And that's a trick I'd never heard of, and I'm totally going to steal when I have to do my first BGA board.
Yeah, right? It's almost like a hack a day or something. You almost learned something, right, from the comments. Yeah, that's really cool. And it makes perfect sense, right? Because obviously the traces are the thing they're giving the most attention to.
This article really did inspire me. I really feel like I should go out and do a BGA board just to get my feet wet. And I remember ages ago talking to Antti Lukatz, who made an FPGA board that was in the size of like a dip footprint. And that thing was absolutely insane to me at the time. And he convinced me to try to reflow one of these. That's actually one of the boards I've ever BGA soldered together myself. And it worked, like I said, worked first time, and he was right. But I also remember being absolutely terrified of doing it at the time. That's the way I feel about BGA layout right now and BGA design. So I think I just got to step up, pick a nice, easy one, and see what I can do.
Yeah, I think terrified first time out is the way we feel about a lot of things, right? That's like human nature, yeah.
I remember being scared of surface mount parts way back when, too. So, there's no shame there.
Yeah, I think it's best summed up with the one comment, currently the last comment on it, that says, "Not my day-to-day, but definitely an article to keep in mind for reading when needed." You might not be there yet, but when you get there, definitely keep this article in mind because it's an awesome resource. I feel like I always pick these classic hardware reverse engineering ones, but I apologize for nothing. Because they're like the bread and butter kind of articles. This one is Breaking Google Nest Hub's Secure Boot. And, there's a lot of things in here that we've seen before in a way, but it's always cool to see these, little building blocks of techniques where you just start with the bare minimum and you work your way up. In this case, Frederick started with the FCC database, which is always really cool. You get a lot of internal shots and stuff. And it from there, it was clear that there was a hidden USB port that wasn't user accessible. There was a little door that came off. So he starts looking at the USB port, and it's the USB port is on a board with the DC power jack, and then that's connected to the main board with a flat ribbon. Looking at it, he says, "Wait a minute, there's too many pins here. Why is there so many pins in the ribbon cable?" For, you know how many wires are in USB, and you know how many you need for DC power. So starts looking at the pinout, and lo and behold, there's a serial port in there that isn't broken out. his idea is that they probably would swap out this little board for like a development version at some point, and they kind of left the serial lines in there. So he comes up with his own little developer board that breaks those serial lines out, and now you have a serial port, which is always, the first step on this kind of hacking. And from there, it's the classic like U-boot fiddling. Can we figure out how to harass U-boot into letting us do something other than start from the internal flash? And in this case, there was no easy, hit D to boot to something else. But if you pushed a certain combination of buttons on the device, it would look for a firmware image off of that USB port that was, not user accessible to begin with. So, you read the article and each one is like, okay, one more step. So now he got to the point where he could force it to look for a recovery image. How do you make a recovery image? And then the article kind of goes from there into more of the software side of it, where it's trying to figure out some way to exploit that. Long story short, and it is quite a long story, get comfortable if you're going to read this whole write-up. But the hook here is the use of the Raspberry Pi Pico, and that is running Tiny USB, which is a cross-platform USB like experimentation framework. And basically using that, he was able to make a invalid USB device. The block size is bigger than usual or something like that. When the Google Nest tries to load the firmware image from this, it chokes on it and hits a buffer overflow, and from there the payload can be loaded, which opens up booting to non-signed images. So it's really a tour de force, and definitely put your big boy pants on for this one. It's not an easy hack by any means, but the end game is that I was able to boot a Ubuntu image intended for the Raspberry Pi on it because they're both ARM. And all the files are released, and you can follow along if you have this particular version of the hardware. It even kind of goes like an after-action report, which I thought was pretty cool because, now that you knew what the bugs were that were exploited, he's like, well, can we find these? And it turns out that the bugs exploited shouldn't even still be in the device because they were raised and fixed twice before. So somehow they're using this very old, unpatched version. I mean, the one bug was found in like 2002 and was patched in 2011. So these are ancient bugs. This isn't like an old version. I think the manufacturing date was like December 2020 or something. So you're talking decade-old bugs in U-boot that are still out there. So kind of don't be afraid to try the oldest tricks in the book because sometimes they're still valid.
I agree with you. I love that he was using a Pico, using a microcontroller for this, because normally this kind of like USB hacking, fuzzing, trying to get an exception through a USB stack like this is something that you'd want to buy an expensive device for, right? Like there are professional USB sniffers and injectors and stuff, and they cost hundreds of dollars. And here he is doing the same thing with kind of a bit of software and a $4 microcontroller. I love that.
Yeah, and we've seen that before too. Like you said, you might think you need this super expensive hardware. I'm reminded of the SuperCon about the, what was that? Hitting the electronics with like voltage spikes to make them do weird stuff. You could buy this expensive setup, or you could get a disposable camera and a little coil.
Colin O'Flynn's like talk on doing it with disposable camera flash units and like a cheesy inductor as the coil, and you just like hold it up to the chip and hit flash and see what happens.
Yeah, you look like these ultimate extremes of the spectrum. Like, well, you could, spend all of your hacking budget on one little gadget, or you can make this thing and it'll probably work, But that's like in the perfect spirit of Hackaday.
Well, in the spirit of how little can you get away with, this next article is the sub $100 Easy 3'd X1 3D printer. Is it more than a novelty? And you know the rule, folks. The answer is no. It's probably just a novelty. But this is a review of certainly the cheapest 3D printer I've ever seen by All 3DP. Their conclusion is, of course, that it's kind of crappy. What's interesting to see here is what exactly they had to do to cut corners to get this thing under kind of the mythical $100 price point. And it includes smaller build platform. So the build platform is a cube that's 100 millimeters on a side. So about half the size in each of the 3 dimensions of a bigger printer. So that's like an eighth of the volume. It prints really slowly. They recommend speeds from like 10 millimeters a second to 40 millimeters a second. Yeah, I don't think I print anything that slowly anymore. It doesn't have a heated bed. It has a cantilevered frame, so they kind of like minimized parts in the frame, which minimizes rigidity, which is kind of a bummer. The thing doesn't have a display, which I think is really an interesting cost-saving measure because, like, I guess it means they don't have to build a whole display board and microcontroller stuff along with that. But, like, you put the SD card in there and it reads the dates of which file was most recently modified. And when you press the play button, it just prints that file out. I actually think that's kind of surprisingly usable given the, workflow that people will be doing, right? Like you slice it on your big computer, write it to SD card, take the SD cards over there and hit play. That'll actually work for that. So it is kind of a minimalist workaround. Anyway, the point is the corners they cut to make this thing work by themselves probably aren't that horrible. But then there's like other quality things that just get knocked on as well. And that leaves this printer as basically something you don't want to buy. And I did like All3DP's conclusion here, which is that for like, $150, $170, you can buy these days kind of a solid intro level printer. And so what are you saving? You're saving $50 and you're getting something that's just significantly less usable. Save your money, don't go to McDonald's a couple times, and then splash out and buy a reasonable kind of $150, $200 3D printer instead of trying to get below this mark. But I remember a long time ago, this used to be like the benchmark. And I remember there were a whole bunch of Kickstarters that were hoping to get below the $100 mark. And, it's kind of fun to see what kind of corners you can cut to make this work. And I think there has been kind of a long history of people trying to get the price down so cheap that just everybody would be able to buy them.
And I saw in the show notes for this one, you had, PrinterBot ? And I was like, those are some fighting words, sir. I started on a PrinterBot and
I know you did.
I had never thought of it as like this cheap, janky thing. But then now I look at it and I must admit that there was some very a strong family resemblance, I have to say. And like the way it's cantilevered out like that, and it actually reminds me right before kind of PrinterBot that version of PrinterBot, because they are technically back now. Right before they kind of folded up, Brooke had this idea that he called the Adoptabot, and I think he was actually shooting for something like $50 was going to be the total. And this looks remarkably similar to the Adoptabot, and I almost wonder if they were kind of inspired, because that was an open source design that he just kind of gave out, and I do wonder if there's some inspiration there. I actually have a assembled Adoptabot on the shelf here, and I'm looking at the two of them, and it's like, well, I kind of see it. I kind of do see it. They do some different stuff, like the belt-driven Z, which is like, how much do you save by not having the lead
screws?
You wouldn't think, but I guess at this point, like anything you can save is worth it. They even got it's all little heat insert plastic, because I guess the plastic itself isn't strong enough to take a screw. But then they do have cool stuff like there's actually a magnetic bed on there, which is impressive, and it doesn't have a heated bed. But the board apparently does have the capability for it. I guess there must be a offset or something on there. It just mentions in the review that the board has capability, but doesn't really expand on what's how hard would it be to actually retrofit one. Not that I'm saying it'd be worth it to get this thing and retrofit a heat bed, because it's But again, to look at the PrinterBots, the PrinterBots never had displays because they were always meant to be used tethered. There was never a file selection because it didn't really work like that. They did technically have like an SD card slot, but it was janky to the extreme. Like you're really meant to use this thing in conjunction with a computer. So I kind of thought that would be the case here, but at least in the review, it doesn't mention that. I could definitely see it if you did want to go to that old school, or it's not even really old school, because now you can get Octoprint, and pair that with this, and it might actually give you a better experience than shuffling the SD cards around.
Yeah, old school is new school again. I was going to say, I actually have Prusa i2. It was one of the original triangle frame Prusas. I actually made it at a workshop with Joe Prusa, among other things. Like, he actually printed out the plastic parts that it's made of over there. And that thing runs on I guess it's a Sanguino. Like, it's horrible, but it only communicates over USB, and so it does all the serial over USB. It's headless in that exactly that same way. And like you say, it's no limitation anymore because you just get a Pi Zero W for 15 bucks. Plug it up to the damn thing, and all of a sudden it's got a wireless web interface. So, I actually run one of these headless machines, and it just doesn't bother me in the least because I run it all over Octoprint.
At the end of the day, like they say, it's definitely not worth it for like the individual for $50, $60 more. But I don't know that necessarily that's who they're targeting. I can see a classroom. If you got to get 10 of these things, and the kids are going to beat them up. And let's be realistic, their demands are pretty low anyway. If it squirts out something that vaguely looks like what they were hoping for, they'll be over the moon. So I wouldn't recommend this for any like individual who's like looking to get their feet wet. But I could see maybe a hacker space that needs a bunch of them just to kind of teach you the basics of how do you get a bed flat, how do you do your first layer. And I think that's kind of what the idea of the Adoptabot was too. Like this is nobody's like full-time printer, but if you could get it into a grade school and get these kids exposed to a technology that we like to think is going to be increasingly commonplace, I think there's an argument to be made there. A project that really caught my eye, and we're going back, I think this is last week, right? But we didn't have a regular podcast. Is the Nokia, which is a team effort. Is actually an entry for the Hackaday prize for the second challenge, I think it is, reuse, recycle, revamp. And the idea here is they take an old Nokia 1680, one of the classic brick phones that you could drop off a building and you could keep going. And they come up with a new modern mainboard for it. Now, technically, as some of the commenters pointed out, it is no longer a phone per se. It doesn't have a cellular modem. It sounds like they couldn't find anything that was small enough to fit inside of it, although with USB-C and Bluetooth and Wi-Fi and all other kind of expansions, it does sound like some kind of external cellular connection isn't out of the realm of possibility. But the main hook here is just to have a surprisingly powerful Linux machine in your pocket, which is, I know for me, was the dream for most of my life until, Android came along and kind of sort of gave us that. Again, it's not a phone, so don't think you're going to be calling anybody on it, although there is a possibility for having, device-to-device chat kind of deals. And I suppose you could run IRC on your little tiny Nokia screen. The idea here is really like a hacker's kind of toolbox, right? That you could run all kinds of Linux tools on there, and you have the interfaces, the hookup of stuff, and you don't have to have a whole laptop for it. I mean, granted, the screen real estate is limited, and you still have a numpad instead of a full keyboard, but I think there's certainly a lot of possibilities here. I mean, I know this is the kind of device that I would have given anything for at one time in my life. Like, this is like the dream come true. And I guess we are a little spoiled by, the power of modern smartphones. So, you go back to something that has a 220 by 280 screen, and it's a little bit of a rude awakening. But there's definitely possibilities here, and I'm very excited to see what the team comes up with. Love the form factor, love how hard, robust it is. This is something you could toss in the tool bag and not be worried about damaging. It's early days, they're still working on it. They're still, I think as of right now, they just hit like revision 3. Yeah, revision 3 on the board. That changed some stuff around. Like they were originally going to have, I guess, GPS, and now they're going to take that out and make that there was a camera, and GPS was originally supposed to be integrated, but now they're moving a lot of that stuff over to like external accessories, making use of the Bluetooth and the USB to hook other stuff up to it, because obviously space is at an extreme premium inside the case. So, it's certainly a niche device, but I think I'm in that niche for sure, and I think a lot of the Hackaday community would be. And I just really can't wait to see where this goes.
Yeah, I think a lot of people got distracted by the old cell phone form factor, and they got their heads stuck on cell phone. This is a Linux computer wedged into this. I love these kind of hacks because there's been, this is a well-proven industrial design. Like these phones, like you say, you could throw them off a building and they'd still work. This is like a nice case. And one of the hardest things for me to design ever is the case for things. It's the packaging that's the hard part. And so here I think it's really clever to just basically design a Linux computer from the ground up, that also happens to fit in this nice convenient case. So I think don't think of this as a phone. Think of it as a Linux computer wedged into a phone case. But then they also threw like a whole bunch of weird and interesting hardware in there as well. Like you said, they did take out the GPS, but they added in a LoRa module, and I guess Raymu does show up in the comments and mentions that they've got kind of limited point-to-point speech working over the LoRa. It's a 433 megahertz LoRa radio. That's kind of cool by itself. It's got Wi-Fi, it's got Bluetooth, it's got a Yamaha MA3 music synthesizer, so you can compose chiptunes on the thing. It's got it's got a Type C port. You can't beat that. It's got an RGB LED. It's just a really cute little mini computer that's also in an awesome phone case that you can pick up cheap and not have to go buy an enclosure and a keypad for.
Yeah, I don't even think it's a hot take to say that you probably couldn't develop a better enclosure, if you tried. Really, like the work has already been done. There's so much engineering went into this, and teams of people making sure it was, feels good in the hand and it's strong and the keys are
field tested for years by like 1 million people. How are you going to beat that, right?
You're not just going to come up with a better case. I mean, and what would it be? Some little 3D printed thing with some off-the-shelf keypad. That would be the weak link in the whole thing. So, yeah, utilize all that research and development. And like I said, cheap as dirt. These things are now considered e-waste by most people. Mm-hmm. It's great, and I think it's kind of exactly what we were looking for in some of these challenges in the Hackaday Prize, right? Figure out a way to take something that is garbage, for lack of a better word,
destined for the landfill.
Juice it up. And, get people excited. And I think there's a lot of excitement about this. I've seen this actually run on a lot of sites. All the tech sites were really excited about this when it first came out. So I think there's always been like kind of this love of these old school Nokias. And anyone who's dropped their modern smartphone and had that little... when they turned it over to see, like, did I shatter the screen or not? We all have wished for the days where you had these rugged brick phones. So it's cool to kind of see a return to that.
My next hack, no tool left behind with the help of homemade shadow boards. This is a cool tool organization project by Scott Prince. The idea behind shadow boards is, like, my grandfather used to have this on his workshop wall. He drew little chalk outlines of all the tools where they hang up so you know where each one goes. Here, Scott is CNC milling them out of a two-tone board, so he has nice little cots for each of his tools to lay in. That's kind of fun. The interesting part here is how he goes about doing it, and that is by back illuminating them so he gets a really good black and white high contrast image, and then uses OpenCV to undo the camera's barrel distortion, depixelize it, do the color thresholding, and kind of all the image processing that you need to do to get the outline of each tool. And then he turns those into tool paths for a CNC machine, and then he can lay them out and just mill the board out, and boom, he has perfect fitting little cradles for all of his tools, and then he can just slide that in a drawer, and everything is completely OCD organized in a way that my basement is not. One of the things I thought was really cute about this is that he actually designed the camera, which is Raspberry Pi based to no one's surprise, inside a stool that he keeps in his workshop. So when he's not using it as a little miniature backlit photo studio, he can actually step on it to reach high things or sit on it. I thought that was a sweet double use. The other thing that's really cool here is he doesn't shy away from explaining that he has to also do a lot of manual touch up here. And so this starts out with kind of an automatic procedure. You put the tool in the thing, you press the button, it takes the picture. He says that's the quick part. He actually does have to kind of remove some of the interior holes. So, he has to make the outline solid, right? Because he wants to mill it out. Some here or there, they're like little small features, and he has to enlarge them, and he has to add thumb holes so he can grab the things out. He estimates actually that he spends, a lot more time doing this manual work than he does with the automatic stuff. Or on the other hand, the automatic stuff is just so efficient that there's only like this last little bit of work to do. Either way, it's a really cute idea and a cute project.
Well, it's funny you describe it as cute because I guess it's because, I have a toddler at home. But as soon as I saw this, I thought like the little puzzle she has where it's like put the duck where the duck goes, put the chicken where the chicken goes. And it's a very similar kind of idea.
Put the pipe wrench where the pipe wrench goes.
Yeah, right. Cut the shape out and get your shape memory up. But it's really cool. I talk about showing off. Imagine somebody's over like, oh, hey, grab the pliers out for me, and they open it, and that look in their eyes, it'll all be worth it when they see how organized you are.
The other thing that I couldn't help but thinking here is that he's doing the shadow of the whole tool. So it's kind of like the maximum size of the tool, but then he's putting it in a little milled in cradle that's only about maybe a centimeter deep. So it's extremely unlikely that the widest part of the tool is going to be exactly at a centimeter deep. And that got me thinking about how you would do this for like an even tighter fit on these funny little beds. Not that that's at all necessary. And that reminded me of a 3D scanner design we saw a long, long time ago. I actually wrote one of these up in 2016, milk-based 3D scanner. And the idea here was that you put your object in milk and then you drain the tub slowly and you take pictures from overhead or from different angles even if you want to. And that line where the milk, the coastline where the milk and the part meet each other gives you a 3D isosurface. And then, as it drains down, you get all of these and you can kind of trace out the 3D object. I wrote this one up in 2016. I actually went looking on Hackaday. The idea dates back at least to 2007. So I'll put up a super historical Hackaday post on milk scanner 3D mapping that's good for you. Great title, Will O'Brien. And anyway, I think that'd be fun for this one because you could just pour a centimeter's worth of milk in the pool. You could put your part down there and then you'd have exactly the outline at the depth that you need to cut it at. Is that taking an already absurd idea a little bit further into absurdity? Why, yes, it is. But as long as you're going to do it. No, I think this is awesome. And, it's just one of those things that shows off what computer control of tools can do for you. And if you couple that with some, imaging on the upfront, that's like design work that you don't have to do. And the combo is a match made in heaven.
I have somewhat mixed feelings about this next project. Post is called HDMI is an attack surface. So here's an HDMI firewall. And that's a pretty strong claim to start with, that HDMI is an attack surface. But I think I could kind of sum it up by reading this excerpt from the documentation for this project. It says, for example, let's imagine you invite a guest for a presentation inside your company. You offer to connect a video projector so he can show his slides. This is the perfect opportunity for the guest to hack the video projector. Next time an employee connects to this projector, the laptop is hacked back, and voila, the innocent guest managed to infiltrate your company network and can exfiltrate confidential information. That's a pretty bold claim. I don't know if this is from a film that is in production or, I'm not 100% sold on the idea of HDMI being a valid attack vector. Our resident security expert, Jonathan, says he's never heard of it being used. But hey, I guess that doesn't mean it's not possible, right? But whether or not we buy the idea that you can be hacked through HDMI, I do like the implementation here. It's kind of cool. We've seen these USB gadgets that cut the data lines and it's just power, right? Which is actually a really good idea. If you're going to plug your phone into a weirdo USB port to charge it, something that cuts the data lines is actually worth having. But you can't just do that on HDMI because there's a certain amount of negotiation that has to happen. It wants to know what the other device is, or it's not going to show anything. So you can't just make a clean cut like that. So there's actually a little chip on here, and you have to go and for the device you want to protect. It's in the documentation. You got to pull out the extended display identification data (EDID). So he gives the commands that you can pull this out and then flash that to the chip so that when you plug it into your projector that you've been invited to use, the projector sees a valid device, the appropriate device, right? And will, send the video down the line. So it is kind of clever in that implementation. And I also like this a little tab on the side of the PCB that says break here if you want to finalize the process. Like once you put the ID on there, you break the board, and then you can see there's a little trace inside that section of the PCB. So once you break it off, it's done, and now it's written. And that actually kind of reminded me of the Prusa Mini, the buddy board.
Right.
They did a similar thing where, like, if you want to write the firmware to it, you got to snap off this little appendage of the PCB, and that breaks the line, and then you can, that lets you write to the chip. So it's a cool implementation. There's a lot of neat little tricks here. I probably won't have one of these in my own collection. I don't think we're quite there yet, but who knows? In a couple years, I might be made a fool of by some rogue projector hacking.
I wouldn't be surprised if you would be made a fool of on this one. This sounds like the sort of thing the NSA would be totally working on. And
yeah, right.
The Snowden revelations and the Ant catalog is 10 years old now, right? And that stuff was a little bit long in the tooth when it was revealed as well. I'm going to throw a link in the show notes. Do not click on it if you have security clearance. You will need to fill out lots of paperwork if you follow this link. Sorry about that. Those of you without clearance, absolutely go click on it. It's a Wikipedia link. This shows you kind of the sort of things the NSA was working on, 10 years ago, 15 years ago. They are trying to compromise basically every device that has, that's a router, that has any sort of computer chip in it. And this doesn't entirely surprise me. Think about smart TVs, right? If you could get a buffer overflow on a Samsung smart TV through the HDMI port, you could do all sorts of bad stuff. And it wouldn't surprise me if one spy agency or another wanted to do this sort of thing. Again, am I going to need this to protect myself? I'm not particularly in that position, but it might be interesting to see how you can do it. And it certainly is a cool thought experiment to see, how much of the bad stuff that could go over HDMI you could block out by putting a firewall in there.
I guess it would be actually an interesting experiment to maybe do like a HDMI honeypot, and capture some of the stuff coming, because it is I2C, I think, ultimately, right? That it uses to identify itself.
Yeah.
So I wonder if you could, use something like this, cut the line, give it your credentials or whatever, and then just capture everything that comes back at you. Who knows? Maybe there's already stuff out there that we're just blissfully unaware of.
My gut says that the engineers who work on making HDMI devices talk to each other are not thinking about the hacker case. I think the idea that people would abuse the protocols is probably not even on their radar. They're just worried about making stuff work. And I bet you they're not worried so much about how people try to break it. So I wouldn't be totally surprised if there were a future in HDMI hacking. I'd love to see you proved wrong. Show me what you got, folks.
You know what? I always try to avoid making absolute statements for that exact reason, because I'm sure, but before too long, if not already, somebody's like, oh yeah?
My first quick hack this week comes from Data Noise TV, a simple RP2040 based audio DSP board. I like this one because it's an attempt to make a you can program it yourself DSP board, mostly for modular synthesizer enthusiasts. The real feature here is the Volt DSP programming language that goes along with this. Looks like it makes it really easy to code up your own filters and funny sounding noisemakers. If you're into that, give them both a look. Next up, inside 3D printing shoes, I don't know what it is with 3D printing shoes. I've seen so many 3D printed shoes. Why do we want to 3D print shoes? Anyway, this one is really interesting because it features an up-close look at a sintered TPU machine that kind of puts out a rubbery plastic dust and then fuses it together with a laser. Just for the crazy 3D printer alone, I think this is a cool video. And last but not least, Nathaniel Felicki, machine learning does its civic duty by spotting roadside litter. This is what do you get if you add machine learning, a Pi 4 camera, and a cell modem together, mount it on a sweet little 3D printed bracket on your car. The answer is you get a camera that can essentially war drive for trash on the side of the road. You drive along, it films the outside. When it sees trash in it, it uploads its GPS location to a database. And then Nathaniel also has a nice software interface that kind of gives you the hot spots around San Diego where people have the most trash by the side of the road. And then you can go and pick it up. This is the sort of thing that it would make a ton of sense for like cities to have in their possession, like for their cleanup crews. I think this could be the start of something really cool.
I like how the comments on that one too. They talked about, the ID and like potholes and that kind of thing too.
Yeah, right? Yeah, why do like public works divisions not do this already?
Once you're running these things around on your trucks, you might as well program to look for all kinds of stuff.
Sons of bitches are scanning our license plates with them in violation of our expectation of privacy. Why don't they fix the damn potholes? Grumble, grumble, grumble.
So my first quick hack is Raspberry Pi simulates the real analog TV experience. We've seen a couple projects like this that use the composite output on the Pi to, pipe out old episodes of your favorite shows and make it look like you're watching real television. Rodrigo took this one a little bit further, though, and actually tapped into the analog tuner on this little old-school black and white TV, so that when you turn the knob to change the channel, a relay is used to kick the actual original tuner back in for a few seconds, so that you get that burst of static and crackle as it goes between shows. The downside is it's built into the TV and not something you can just hook up to, whatever old CRT you got hanging around. But it is a very cool trick, and, you could probably do something similar with some clever software, if not for the physical experience of turning the knob. Next up is a handy breakout board for e-paper hacking. This one comes from Aaron Christoffel, who is hacker of all manner of embedded gadgets, and for the last probably a year or so, he's been looking at these electronic price tags that have the e-paper screens and trying to repurpose them, whether it's using the screen separately or actually talking to him over the wireless. He has a need for an easy way to sniff the communication between the screen and the microcontroller on these boards. He says in the video here he was previously scratching off the solder mask and soldering little wires to the traces, and it was a nightmare, and you damaged the boards and bad. So he came up with a very simple breakout, and I mean it is very simple. You got the flex connector. I think it's a 24 pin, 0.5 millimeter pitch, which he's kind of identified as the common connector for these displays. You got a connector for that on either side, and in the middle you've got your regular 2.54 millimeter pitch header. So you can put your little jumpers on there, hook up your logic analyzer, and without doing any damage, you can get a capture of what the microcontroller is saying to the screen. He's put the file out for free if you want to get these made up, or he has a link through one of the fabs where you can toss him a percentage of the purchase price if you have it made for you. And my last quick hack is an impressively functional taco bot. This one comes from VJ Miller, and, we see these little meme, funny, ridiculous machines come our way a lot, and they're always fun to see these, like, Rube Goldberg machines flailing away. The one that surprised me about this one is it appears to work really well. It grabs the tortilla and it puts it on the thing and it rotates it. It kind of folds it into that, handheld shape. It drops the meat, drops the onions, the lettuce, and it kind of does everything you'd expect it to. And I watched the video and I immediately thought I would pay money to see a little box with this thing inside of it making me tacos. I've seen it for like ice cream, where it'll make you a little ice cream sundae, very similar kind of setup. The main problem was that while the meat and cheese came out pretty well from the little hoppers, the wet stuff like the lettuce and the onions and tomatoes were much less willing to be dispensed on command. And that immediately made me think of the awesome series of articles about handling bulk material that Anne wrote up. So we'll put that in the show notes too. And this is kind of like a really cool real world example of how hard it can get to make weird, wet, odd materials behave on command.
All right, that brings us to our can't miss articles. These are long form articles written by our fantastic Hackaday staff. And this week I'd like to pick up Al Williams's Eliza and the Google Intelligence. The big hubbub about Lambda stems from the fact that one of Google's researchers, Blake Lemoine, A, got fired, and B, wrote up long discussions he's had with this AI natural language chatbot, and he's not 100% convinced that it hasn't become sentient. And so you absolutely need to click through to the linked transcripts from it. I was super impressed by it until after the fact I did read that these are kind of cherry-picked and put together from a bunch of different discussions, which kind of bums me out a little bit. But I do have to say, on my first read through, man, that is an impressive chatbot, if nothing else. He asks it questions about parables. He asks it questions about justice and injustice. He asks it what, its favorite part of Les Miserables is. A lot of this, unfortunately, is going to be out there in Cliff's Notes. And so if the AI has studied Cliff's Notes, it's going to already have something smart to say about these things. I hear you all muttering, how different is that from an average high school student? I don't know the answer to that question. At one point, he asks it to make up a story, and that's maybe the least convincing part of it. But at least in kind of the public coverage of this kind of raises the question of whether these like hyper-complex neural net-based natural language processing machines, know that they exist. Are they conscious? Are they sentient? Al's take is no, they don't, and humans are super good at anthropomorphizing things. Like, you draw two dots and a curvy thing under it, and like everybody sees the smiley face there, right? Like, we are just programmed to see other humans in things, and some of the effect here may be just kind of wishful thinking. Some of the interesting discussion I've seen about this includes things like, well, do we need to rethink the kind of Turing test, which was this classical thought experiment to say whether an artificial intelligence is intelligent or not, depending on whether people can tell whether it is or not. That's a really interesting question when these kind of machines have a big enough corpus inside them that they can give out responses that are indistinguishable from human responses. It kind of breaks the Turing test, even though on the other side, it's demonstrable that they're just kind of like a weighted average of previous observations. I don't know. I think it's awesome. I love some of these crazy AI things and the nonsense they spit out.
Like you said, it's very impressive, right? At first glance. But I don't know. The whole time reading that, it's had this weird feeling. It never really proved itself to me, because it just seemed like it was like there was even one question I think it was asking about, how can we save the planet from climate change or something. Like it even gave links to the pages it was pulling its talking points from.
Right.
Which is kind of what I would expect from a glorified search engine. And,
links in the show notes.
Yeah. Yes. Here is the links. There's absolutely a place for such technology, right? We all have these like personal assistant things on our smartphones now, and if you can have a natural conversation with it and it can retrieve you links, hey, that's great. But it's not live, that doesn't make it a sentient thing. It's just doing what it was designed to do and doing it very well. like you said, when it was asked to make up the story, that was a real weak story. Like that
Yeah.
was if I asked my 4-year-old to make up a story, I think I could have done better than that. It was a pretty lame story. And, I think that what really kind of bugged me about the whole thing was like so many of the questions were very like on the nose. Like, I mean, how could you prove you're sentient? How could you prove that, and it struck me as a bit like asking a cop if they're a cop, right? Like you can't just ask that because they're prepared for that question. Like that's the one thing they were waiting for. You can't, you gotta be a little more clever than that. So, just asking it directly, are you sentient? Just the fact that it responded yes doesn't make it true. Like there has to be some kind of, like you said, there has to be some kind of a better test. And I'm certainly not, I don't have a solution. I don't know what the test is. But to me, this was just a system that was doing exactly what it was supposed to do. And also, I mean, we can't ignore the fact that this individual got fired too. So, you have to kind of take that and, is this something they're just trying to drum up some publicity for themselves because they lost their job? There's a lot of weird extenuating circumstances going here, that is outside the scope of the software itself. So it's, yeah. It's perfect fodder for, clickbait articles and stuff, but I was not convinced. And Al must have had some real strong opinions because we didn't even have time to ask him to write this one. I remember seeing this and I was like, oh, I bet Al will be interested, and then boom, it was done. So he must have woke up with a shot. Or like, oh, someone's making claims about AI, and pounded this one out. And I'm very glad for it because it was very timely and a lot of good conversations.
Yeah, I love these kind of chatbots. I've been a fan of chatbots from the way back. I remember running a version of Eliza that he talks about in the story. Oh my God, on dial-up on the VAX computer at Vanderbilt where my dad was working at the time. They had an Eliza version, and so I'd like type to it at 300 baud. And then later, when technology got a lot better in kind of like, I guess it was 1989, 1990, that zone, there was a Scientific American article that I'll throw links in the show notes to about a Markov chain-based chatbot called Mark V. Shaney. And I actually tried to implement this on our old 386 PC at the time, and I didn't have enough memory, and I wasn't good at writing stuff that did disk access at the time. But like I remember exhausting the machine's memory, building out this like super big 3-dimensional array of the probabilities. And so the idea behind these Markov chain bots is you just chunk through a lot of text and you say, if this word follows this word follows this word, I, assign it an increased probability. And then I go to the next one. And then it's this word follows this word follows this word. And then you get an increased probability for that one. And you just train it by reading in a corpus of text and, bumping up the probability for all these triples of words that appear in a row. And then you feed it 2 words and you just let it go from there. And so it says, oh, I've got these 2 words. And then it rolls the dice and picks the 3rd word after that. And then it's got 2 words, and then it rolls the dice and it picks the next 3rd word, and it just goes on and on and on. And you can get shockingly good nonsense text out of these type of chatbots. And I'm really tempted now that we have more memory and I'm a little bit more savvy about coding up sparse matrices and stuff, about revisiting this project because, this is from a long, long time ago and it uses kind of demonstrably old and boring logic behind it, right? Like it's literally just a Markov chain that you let run wild. But it was interesting enough at the time that somebody was running one of these bots on Usenet and responding to people. Penn from Penn and Teller actually wrote it up for Wired. I'll throw that link in here too. It's really funny. Anyway, it's good to play around with and kind of proof that you don't need to go the full neural network way to get intelligible speech out. The problem, of course, is that it only uses 3-word runs. Every once in a while, it like jumps off track. Like it goes from 2 words that belong together to one that belongs together, but then they don't all fit together. And so it makes these like really strange U-turns. And I think that's part of its charm. But if you're looking for like, strictly coherent prose, it may not be the one for you. On the other hand, what Google and all them are doing is essentially just, expanding out from word triples to, word quadruples, quintuples. I mean, they're throwing millions of dollars and bazillions of gigabytes at training these things. Anyway, that it's doing basically just the same sort of thing, but with a much bigger input corpus and a much more sophisticated output algorithm. And I think, if you step back and look at it from that perspective, you got to say, no, this thing isn't sentient.
Well, I think speaking of rolling the dice and seeing what comes out of a decidedly non-sentient program, we can't move on without mentioning the post that Jenny List wrote, for lack of a better word, this week, called "A 3D printed Nixie clock powered by an Arduino runs this robot." And that title was actually what she fed into a text and image generating AI, and the resulting picture and body text is remarkably passable. I mean, it's kind of gibberish, but not the exact right kind of gibberish we're looking for.
Yeah.
But if you took like one or two sentences in isolation, it's pretty good. I mean, it name drops like Prusa i3 and stuff. Like it gets us. It worryingly gets us.
Yeah.
And I think this is an experiment we've kind of threatened to run for a while now, just letting an AI type out a Hackaday article and see how close it can get. And I think our jobs are secure for the time being, but maybe not as long as I would like, because it was not bad. And it was run. There's a little tag that says confused yet, and then she explains kind of the process. But I almost wonder if we hadn't added that.
Yep.
Could we have gotten away with some people just being like, that was a weird one, I'll move on to the next hack. Well, my can't miss article this week is how far can you push a 500-pound small electric car? 4 years of the Hacky Racer. For those who are only listening along, it's 500 pound, as in costs 500 pounds and not the weight, because these things are far smaller than that. I can't imagine they weigh nearly 500 pounds. This is the British take on American modified Power Wheel racing, which now that I wonder, do they not have Power Wheels in Europe? Do they have to make them themselves? Because these are very clearly completely custom, the custom chassis, everything. They do have the same kind of like outer trappings as, and Jenny mentions that they wanted it to look kind of like the American version, so they all look like fire trucks and Jurassic Park Jeeps and all kinds of silliness. But they actually have to make the bodies because I guess they're too big to export, perhaps. They don't have them over there. This is an on-location kind of thing, which is also great that we're able to start doing that again after some real sucky years. She was able to go and check out, she says, last weekend, from the perspective of whenever this was written. It's an interesting talk about, this European version of something that we've seen at Maker Faire, they're racing these little things around, and how it's evolved over the years. What I think specifically interested me is the evolution of the technology that Jenny kind of goes into. And she actually wrote an article, I think, in 2020 about, basically they started with the little hoverboard motors or motors imported from other stuff, and none of them really were ideal, and somewhere along the lines they started modifying alternators, automotive alternators. One, because you can get them cheap as dirt, right? You go to any junkyard and get them all day. Two, as kind of Jenny pointed out in her earlier article, that it's unusually for a modern automotive component, they're actually made to be taken apart because there's a huge market for refurbing alternators. It's all, it's kind of a consumable, really, on a vehicle, and so they make them so they can be easily refurbed and sold second time around. So they are easy to take apart and easy to understand for the most part, again, compared to what's usually lurking under a modern hood. So they lend themselves to this kind of modification, and they, while not designed as motors, they actually do a pretty serviceable job, and it kind of goes into some of the unique characteristics of these things. The way they're designed, again, because they're meant to generate, instead of being a motor, that you can control the torque by how much current goes through the coils. And that one of the kind of areas of research that they're doing now for these racers is they're using controls at this point, like manual, like there's little toggle switches that are hooked up that will give more current to the coils to torque up the motor, but then it lowers the top end speed because like the back EMF and like the motor controller can only handle so much of it. So there's a little bit of like a tactical application there. It's not just, hold the pedal down and hope for the best. You need to kind of work your controls and get the most out of your machine. And also a lot of these apparently are done off-road compared to like the American version, which is usually in parking lots and stuff. So there's definite skill there where like when to apply more torque versus when you get the top speed. And she also mentions that some of the real cutting edge designs are doing like an automatic thing that will make that decision on the fly and kind of give you the best torque for your given speed and stuff. So it was an interesting look at how they do things across the pond and the technology that went into it. And after reading it, I am strangely compelled to get an alternator from the junkyard and see what I can do.
Absolutely. I think that was exactly my response too. I love the idea, and this did come from, as you mentioned, an older article of Jenny's, using the alternators as motors by just kind of energizing the other coil and then use it as a three-phase brushless motor, essentially. And that's really cool. And then by running more and more current through the energized one, you can make it have more or less torque. She does say that not all the people in the race she saw were doing that. A lot of them are using like fixed resistors and just putting, a certain amount through there. And then someone actually did it with a relay so that they could have two different resistors and they could switch it in one way or the other. And I think that's pretty cute. I do think this is kind of, like she says here, and like you suggested too, this is kind of right about at the cutting edge of something interesting. And that is when people start to do like software controlled torque on these motors. And that's going to be really sweet. And I do want to see what happens there and how they push this. And I totally agree with you that this makes me like want to build some kind of dangerous, dumb go-kart for my kid for no good reason at all, except that you can. And what struck me here is that Jenny's takeaway was that, motorsport is like only for the like super deep pockets. And these kind of like backyard motorsport competitions like this or lawnmower racing are kind of like, the antidote to formulas that take themselves too seriously, she says. And I agree with that. I guess Lewin's written some articles about getting into, gasoline powered motorsport on the low end and on the hacker end of things. And this is like one step undercutting that even more. When you could pick up an alternator for, $20-$30 and then the driving electronics for another $50, all of a sudden you've got, a motor and the whole thing only costs you $100. Then you can spend some money on the chassis. I think it sounds like a whole heck of a lot of fun. And I'm super jealous that she got to go see it and I didn't.
Yeah, right?
That about wraps it up for this week's podcast. If you'd like to say anything to us, drop us an email, editor@hackaday.com. If you see anything cool or do anything cool, tips@hackaday.com. Links you'll find over at hackaday.com/podcast. And until next week,
keep on hacking.
Dude, I've forgotten everything. It's really funny. Professional, ladies and gentlemen.
Marginally disappointed. No one's figured out the hidden message yet, but I have high hope.
I mean, it earned its nickname, the Wobble Bot. All right, you got to shoot that guy. Totally missed the main point here. I figured it out. I don't think I'm going to put any of this in the podcast. We'll see.